best way this probably will work for the 2.4 complex numbers lecture is I'm just going to go through all the problems kind of as fast as I can. And if you want to, let's say on the DIYs, do it yourself, what I would do is pause the video and then give yourself that time to work out the problem and then watch me solve it and see if we have the same answer. So the big thing here is with complex numbers, where are they coming from? And we start with the fact that x squared plus 1 equals 0 would be a graph that is shifted up 1. So that U-shaped graph shifted up 1. Does it really touch the x-axis? Well, no, it doesn't. So it doesn't have any real, what we would say, any solutions that we've been looking at. It doesn't touch the x-axis. It doesn't have any x-intercepts. So if mathematically all you did is just threw those out every time, theoretically you're throwing out half the problems. Half the problems that don't touch the x-axis, half of them would or something. So what we're going to look at then is somebody thought of and defined that I can be related to the square root of -1, which then means I squared is -1. So keep that in mind. We write complex numbers in the form a plus bi, where a stands for the real part of the number and b stands for that imaginary part of the number. And so when somebody says write it in complex form, they're talking about a plus bi form. The first part here, these examples, we're adding, subtracting, and multiplying. So when you add, fairly intuitive. Intuitive means you probably could do these problems on your own. You wouldn't need anyone to teach. So if I'm going to add, I would add the 9 and the 2 together. Add them, and I'm going to get 11. And then you would add 2i and 6i. So what's 2i plus a -6i? Well, that's -4i. So there's your first answer, 11 minus 4i. Example 2, when you subtract, my suggestion, excuse me, when you go to subtract, is to distribute the negative sign. So you have 3 plus 4i minus 5 plus 2i. So by looking at this, now I can put my 3 and 5 together. 3 and 5 would be -2, and then you put the 4i and the 2i, and I'm getting 6i. So there's a good answer. So that's adding or subtracting. It's no different than putting like terms together that we've done all along. So again, next one's a DIY, so do it yourself. I would pause the video right now, and then come back and look at the answer. If you were to add these together, again, I might distribute the negative sign through there, so you'd have 4i plus 3i, not 3i, just positive 3 minus 5i, and then there's nothing in front of the parentheses, so it's just plus 2 minus 6i. So when we look at this, I have a real number 3 and a real number 2, so that gives me 5, and then I have an imaginary 4i, imaginary -5i, and imaginary -6i. So that would be -7i. So double check that your answer is the same thing. If you go to multiply, nothing really changes, just distribute -10 plus 15i. Here you can FOIL or a box method. So 2 times 3 is 6, 2 times 3i is 6i, -4i times 3 is -12i, -4 times 3 is -12i squared. The real difference comes from right here. I'm going to write this in. I squared is -1. With I squared being -1, I really have 6 plus 12i. That's -12 times -1, which is positive 12. So I get a total of 18 for my real number. And these two together add up to -6i. So FOIL or box method, nothing really changes. It's just that you have I squared to look at. Here's another DIY. So go ahead and pause the video and come back and look at the answer. So if I multiply, I get 16 and 20i. And then if I multiply these two, I get negative 20i. And if I multiply those, I get negative 25i squared. Notice that these two will cancel out because they're one's positive, one's negative. Again, I squared is negative 1, so it's really 16 plus 25, or 41. So when you check your answer, you should be getting 41, which is a pure real number. There's no imaginary part to it. This is important to understand what's happening there because 4 minus 5i and 4 plus 5i are important. Here, if we do example 7, don't forget, let's write it out twice. That's 5 minus 3i and 5 minus 3i. So there are two of them. So again, pause the video if you want. 25 minus 15i. Then you do minus 15i. Then you do positive 9i squared. Again, I squared is negative 1. So what you end up with is 25 minus 9, which is 16, and negative 15 and negative 15 is negative 30i. So that would be your final answer. Now we get into a definition, and you need to know this definition. A plus bi and A minus bi are what are called complex conjugates. You should always write the real, then the imaginary. I will give you a hint. When you get into some of the web work problems, they give a couple problems where they put the imaginary first and the real second, so make that change. So what is the conjugate of 7 minus 3i? It's 7 plus 3i. Normally we'd multiply these together, so pause your video. We've already done one, but pause it. Product means to multiply and multiply by the conjugate. So I would have 6 plus 2i was given. 6 minus 2i is the conjugate. Now, you don't have to worry about the middle part because you get 12i and negative 12i. They're always gone. They'll never add up to 0 every time. So just do the first, in FOIL. Don't do the OI. If you know it's the conjugate, just multiply first and last. So you have 36 minus 4i squared. I squared is negative 1, so it's really 36 plus 4, or 40. So you can multiply and get a real number. All right, dividing is a little bit different. It's something totally different. So we're going to do 3 plus 6i divided by 2 minus 5i. The key here is we're going to multiply by the bottom conjugate. So I'm going to multiply by 2 plus 5i. However, you can't multiply the bottom of a fraction only. You need to multiply the top. So you're going to multiply by 2 plus 5i also. So remember, all that is equal to 1. That's a sneaky form of 1. So when you multiply by 1, nothing happens. You don't change it. We're going to change the way it looks, but not the value. So on the top, you have to do a full-on FOIL. 3 times 2 is 6. 3 times 5i is 15i. And then 6 times 2 is 12i. And 6 times 5 is 30i squared. On the bottom, though, these are conjugates, so only the first. 2 times 2 is 4, minus 25i squared. I don't have to do the OI. This is negative 1, this is negative 1, so I end up with 4 plus 25, which is 29, all over 6 plus 30, or excuse me, 6 minus 30 would be negative 24, and then these add up to 27i. So you could write it like that, I'm totally okay, or split it into negative 24 over 29 plus 27 over 29i. Either one is totally fine. So that's all you're doing, is you're multiplying by the denominator's conjugate. So the bottom one here, or example number 2, we would do 3 plus I over 3 minus I. So the denominator's conjugate is 3 plus I over 3 plus I. So again, the bottom turns out to be 9 minus I squared. Only the first and the last. Then on top, distribute 3 times 3 is 9. 3 times I is 3I. I times 3 is 3I. I times I is I squared. So what you end up with is 9 minus 1, which is 8. 3 plus 3, which is 6I. And on the bottom, this is also negative 1. This was negative 1 here. But this is negative 1, so you end up with 9 minus negative 1, or 10. So what you'll notice is that all three of the numbers, 8, 6, and 10, are divisible by 2. Or split it up into 8 over 10 plus 6 over 10I. And 8 over 10 turns into 4/5. And 6 over 10 turns into 3/5. I would probably be a good answer also. So here's a DIY. Go ahead and pause the video and then come back and check your answer. So if you're coming back, it's 3 minus 2I, 3 plus 2I, and I would multiply by the denominator's conjugate. It just so happens it's the same as the numerator. Nothing to do with that. That's just the way it was written. 3 plus 2I, the denominator's conjugate is 3 minus 2I. So distribute the top. You get 9 minus 6I. Minus 6I plus 4I squared. All over 9 minus 4I squared. So on the top, all your I squareds are negative 1. So on top, you have 9 minus 4, which is 5. Negative 6 is negative 12I. All over 9 plus 5 would be 14. So probably, or excuse me, 13. 9 plus 4 is 13. So probably the best way to write this is just go ahead and do 5 over 13 minus 12 over 13I to keep it in that A plus BI form. All right, some complex solutions. So one of the things that we'll start doing is how do you simplify? And what we want to make sure we're doing is always dealing with the negative first. You can't do anything until you get that out. So instead of negative 5I, you can think of it as the square root of negative 1 times the square root of 5. Well, what's the square root of negative 1? We're learning that it's I, so pull the I out front. Whether you write it I times 5 or root 5 times I won't matter to me. So again, I would pull the I out front right away. What are some numbers that 24 goes into, or go into 24? That's 4 times 6. Which one of these can you take the square root of and get a nice number? Square root of 4 or the square root of 6? Well, the square root of 4 is 2. So when you look at this, I would write it as the 2 comes out front next to the I and leave the square root of 6 in there. So you can write it 2I root 6 or 2 root 6I. If you write it this way, just be careful that the tail does not go over the I. We don't want that to happen. So be real accurate. All right, so on these pages, we're just going to be simplifying some of these expressions and seeing what happens. Negative 27 and negative 12, I would pull the I out front, and this can be written as 9 times 3. And I would pull the I out front, and this can be written as 4 times 3. So when you square root the 9, I get 3I root 3, and over here, square root the 2, I get 2I root 3s. So when you look at this, they're like terms. The coefficients are 3 and 2. So the answer becomes 5 root 3I, I guess, if you want to keep the I at the end. 5 root 3I. So a couple DIYs, pause the video, do them, and then we'll come back and you can check your answer. So here we go. I would pull the I out front. The square root of 80, the easiest is to do 16 times 5. Divide by the perfect squares. Then pull the I out front again, and that could be 9 times 5. So this is 4I root 5. This is 3I root 5. And if you add those up, you have 7I root 5. Or 7 root 5I. Either the same thing. If I multiply 4 minus I root 2 times 4 minus I root 2, what are we going to get? So I have to do 4 times 4 is 16. 4 times I root 2 is negative 4I root 2. Negative I root 2 times 4 is also negative 4I root 2. And then when you take the negative I root 2 times the negative I root 2, you get positive I squared times 2. Again, negative, or I squared is negative 1. So what you have is 16 minus 2, which is 14. And then negative 4I root 2 and negative 4I root 2 is negative 8 root 2I for a good final answer. So now we're going to do a quadratic formula. So remember, this is your A, this is your B, this is your C. So when you do the quadratic formula, you're doing negative of negative 4 plus or minus the square root of negative 4 squared minus 4AC all over 2A. So the negative of a negative 4 is positive 4 plus or minus the square root. Under the radical, I have 16 minus 20. 16 minus 20 is negative 4 all over 10. So this is one of those quadratics. Normally we would stop and say there is no real solution. But now we can keep going. So I pull the I out front. So I have 4 over 10 plus or minus, I guess, let's pull the I out front, and what's the square root of 4? 2. So I get 2I over 10. By splitting them into their two parts, both pieces of the numerator over the 10, those of you that want to use the calculator math enter to reduce it, you can. 4 over 10 reduces to 2/5 plus or minus 1I over 5. Dividing both those by 2. So I guess the two answers are 2/5 plus I over 5 and 2/5 minus I over 5. And again, this one could be written 1/5 I here and here. So pause the video, solve your own quadratic formula, and we can put the answer up there. So if I do the quadratic formula, we're looking at negative of a negative 4 plus or minus negative 4 squared minus 4AC all over 2A. So you have 4 plus or minus 16 minus, so what is that? 16 minus 60. 4 times 3 is 12 times 5 is 60. So 16 minus 60 is negative 44 all over 6. Well, negative 44 can be broken into 4 plus or minus I, and you'd have 4 times 11. Well, which one of those numbers can you take a perfect, or is a perfect square? It's the 4. So now you have 4 plus or minus 2 root 11 I, technically all over 6. Well, 4 over 6 is 2/3. 2 over 6 is 1/3, so this would be positive root 11 over 3 with the I behind it. There are your two answers. And the last one here, x squared plus 4, because there's no b term, there's 0b, I would just subtract 4. Square root both sides. Remember, this is an even power. So when it's an even power, we want to remember our plus or minus. And the square root of negative 4 is 2i. So there are the final two answers. X plus or minus 2i. So the last thing here, complex numbers have to be equal. Their parts have to be equal. So the equal signs in between. So what's it going to do? The 4 and the A have to be the same, and the B and the 6 have to be the same. So what I would write down is 4 equals A, or A equals 4. And then the red ones, your negative B has to equal 6. So if you divide by negative 1, B equals negative 6. That would have to be your